Hello, I'm Donna Curry from the SABIS Professional Development Center for Mathematics and Adult Numeracy at Turk in Cambridge. Today we're going to explore the college and career readiness standards for mathematics. There is no way I can tell you all about the college and career readiness standards for math in 5 to 8 minutes. In fact, I'm not sure I could do it in 5 to 8 hours. So what I'd like to do is spend a few minutes trying to pique your interest in looking more closely at the college and career readiness standards on your own. Have you ever gotten frustrated when students add 1/2 and 1/4 and get 2/6? Don't you wonder how many more times you're going to have to tell them not to add numerators and denominators? Well, we'll see shortly that the college and career readiness standards can help ease your and your students' frustration. Think about what doing math means to you. If doing math immediately conjures up visions of decontextualized computation problems, fractions, decimals, maybe some x and y equals z images, then the college and career readiness standards will be a welcome change for you. The college and career readiness standards are about doing something with the math concepts or the computation. They're about using fractions in order to figure out how much to cut, about what portion of the population wants to do away with something. They're about using numbers, maybe the results of those computations, in order to make a decision, communicate information, and even try to influence. None of us ever just does a multiplication or division problem without a purpose. The college and career readiness math standards have two parts. There are the mathematical content standards, which represents the content that you're used to teaching, fractions, algebra, data, etc. There is also another part to the college and career readiness standards for math, the standards for mathematical practice. Of these two sets, the most important element of the college and career readiness standards is a set of standards for mathematical practice. They are the heart of the college and career readiness math standards. Some of these math practices will make immediate sense to you, but others you will need to mull over and do a good bit of exploration to truly understand what they mean. They are the habits of mind or thinking skills of a mathematically expert student. Without the mathematical practices to guide our instruction, we might help students develop isolated skills, but not how and when to use those skills proficiently. The math practices focus on how students think critically as they address math concepts. These practices are about reasoning when doing computation and critically analyzing why a process does or does not make sense. No matter what workbook or level you're working with, the 8 mathematical practice standards are a guide to good math instruction. Turn to page 48 in your College and Career Readiness Standards document to see a description of each of these 8 standards for mathematical practice. If you want to read about all 8 now, go ahead. I encourage you to do so. I'll wait for you. Then I want to address just a couple of them briefly. Notice that the first math practice is about perseverance, so critical for our students who often get frustrated right away and just wait for you to show them how to do it again and again. We need to give students engaging problems and allow them productive struggle so that they can learn to persevere. We know that students' expectation is that they want an immediate answer. Solving serious situations involving math is messy. Think about all the challenges you face in considering buying or leasing a car. If you didn't persevere, you'd still be driving your first car. Math Practice 1 describes that same perseverance that we want for our students. By the way, Math Practice 4, Model with Mathematics, does not mean to go to the board and model how to do a problem. It means to develop models of real-life phenomenon. Let's use my hourly wage of $10 per hour to illustrate this idea. At a basic level, students might create an in-out table to illustrate the pattern that they see over time. At a higher level, they might use that in-out table to create a graph to model the pattern that is happening with my wages. And at a more advanced level, they can create an equation that models the same real-life phenomenon. You will want to explore these mathematical practices again and again to begin to feel comfortable with them. I'd like to move now to the College and Career Readiness Content Standards and explore those briefly. In order to help our students learn to think as suggested in the math practices, we can use the College and Career Readiness content standards to guide us. The College and Career Readiness standards are structured very deliberately. They are not a set of isolated skills like we too often see in workbooks, which look like the same workbooks with the same problems that we saw when we were in school 17 years ago. The standards, if used as intended, help us shift our instruction. There are 3 key shifts to help your students move beyond thinking of math as rote computation. The 3 shifts are focus, coherence, and rigor. If you want to read a little about them before I give a couple of examples, please feel free to do so. I'll wait for you. Information about the key shift is on page 44 and 45 of the College and Career Readiness Standards document. I want to point out a couple of things about how the standards help you teach to these shifts before you explore the entire math section of the College and Career Readiness Standards document yourself. One of the key shifts is coherence. Coherence involves designing learning around coherent progressions. In using the standards as intended, you will help students continue to build on what they already know. They're not like those workbooks that just switch to a new isolated topic for each chapter. Do you remember some of the rules we learned when we first started learning formal math? When you subtract, always put the larger number on top? I only wish this was always true. My checkbook would be in a lot better shape. And what about this rule? Think about how this rule relates to fractions, or not. And remember this one? Often we teach fractions in isolation, even telling students that the rules no longer apply when we get to fractions. First, we should not have to teach the rule to begin with. Instead, we should be helping students understand what the operations mean. We know that we often teach and reteach fractions, only to realize that students can't apply any of those rules when they get to an abstract algebra problem. Teaching to the standards can help fix that issue. First, the standards focus on the understanding of what the operations mean and how they are integrally related. That means understanding that multiplying means something more than just that the total gets bigger. Look at the standard from a first grade level. Not only does it talk about understanding the relationship between addition and subtraction, it also explicitly mentions 2 key properties of numbers, the commutative and the associative properties. By the way, you can find this standard on page 52. And once students begin to explore multiplication and division, they are again expected to understand the relationship between them, not just show how to do the computation. And they continue to build on their bank of number properties, this time with the associative property. This standard is a 3rd grade standard, so there is no reason our adult learners should not be learning these properties as they're learning their basic operations. You can find this standard on page 56. Fraction work should build on whole number operations. It should not be taught in isolation with no connection to whole number operations. Look at the fraction standards on page 62 before going to the next slide. I'll wait until you read over those standards, then I want to highlight a couple key points that I want you to notice. Notice that this standard begins with the verb build. Students should understand that fraction operations build on what they already know about whole numbers, so the rules should be the same for both. This standard begins with the verbs apply and extend previous understanding. Again, these standards help you as a teacher be more coherent in your instruction. And I want to point out this standard, which talks about using visual models. A visual model is a way to help students gain conceptual understanding. Visual models, such as area models, help students see why a fraction multiplied by a fraction is a smaller amount. And that same visual can be used with whole numbers to help students understand why the multiplication procedure or algorithm works. So, the key shift of coherence focuses on a developmental continuum rather than sets of isolated skills. This is just one example of the many progressions that form the College and Career Readiness Math Standards. Nope, Unfortunately, you won't find a ladder like this one here in the document. I made this one up so you could readily see the progression. You might explore the standards in depth with other teachers at your program so you can create your own stepladder progressions. This progression is focused on properties of numbers, which, as you can see, begins at the most basic level. The shifts also focus on something called rigor. No, in this context, rigor does not mean harder. For the college and career readiness math content standard, rigor means the pursuit of conceptual understanding, procedural skill and fluency, and application, all with equal intensity. I think most of us as teachers do a pretty good job of focusing on procedures. Remember earlier that we talked about how that was not all that was involved in doing math. But how much do we focus on conceptual understanding? How many of our students understand key concepts? Or have they just memorized procedures, sometimes quite poorly? Possibly many of us don't teach conceptual understanding because we have only learned procedures ourselves. A simple example I'll use again is fractions, to illustrate what happens when someone knows more than just the procedures. If students understand that division means taking chunks or groups out, then they could build on what they already know happens with whole numbers. Before moving on to the next slide, solve the fraction problem 1/2 divided by 1/4 and think about how you solved it. Did you use the procedure you learned in school and are possibly teaching to your students? Or did you remember that division means that you can take chunks of quarters out of a half, so the answer of 2 makes sense. There are 2 quarters in a half. In order to develop conceptual understanding, students need opportunities to explore how and why the operations work as they do. That's why some standards focus on developing visual representations, which help show why some of those procedures work. Let's look again at the progression for properties of operations. Notice that each standard begins with the verb apply. The college and career readiness standards give us the tools we need to help our students become capable math thinkers so that they can apply math concepts in a variety of situations. Many of the standards are written to obviously focus on a particular aspect of rigor, either procedural fluency or conceptual understanding or application. You should start to notice those as you read the standards more carefully. Why don't you take a couple minutes and explore some standards now? Pay close attention to the verbs. In the college and career readiness standards, the content is referred to as domains. You can see in this chart how the content progresses across levels. For example, the blue represents number and operations, which begins at level A and moves across the levels. The domain names change and the content changes, but the domains in blue are still related to number. Whereas the orange focuses on algebraic thinking across the levels. But you can also see the content to be covered within a level. Even at level A, content includes not just number and operations, but also algebraic thinking, geometry, and measurement and data. In fact, if you look closely at the standards, you can see that content like data and geometry are ways for students to apply their understanding of numbers. At level A, students use operations like addition and subtraction to answer questions about data, like how many in each group. Notice that the graphs are also simple bar graphs with no more than 3 categories. At the next level, level B, students use picture graphs and bar graphs with 4 categories. They also use halves and quarters because at this level, they're beginning to learn about benchmark fractions. The college and career readiness standards can help you so that you're not teaching fraction procedures yet one more time, and the students can forget yet one more time. But they won't help you if you don't dig into them and use them. I challenge you to start to read the standards, including the information on the key shifts and the math practices. And if you're feeling uncomfortable about what you're reading, give the Sabas PD Center for Mathematics and Adult Numeracy a call. If you have never thought about what it means to visualize a fraction operation, give us a call. If you don't know what algebraic reasoning is or how to teach it at a basic level, give us a call. And if you just want to learn more about us, give us a call. Thank you.